Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to extend the notion of solving linear equations into more than one variable. So far, we were working only with one variable, call it X or R or A, doesn't matter, but just one. Now, we have two of them. Later, we'll see how that shows up in reality. What's the meaning of two variables and two equations? Notice that if I have only one equation, if I have only one variable, I need one equation to find its value, if it exists. If I have two variables, I will need two equations. And that's why in each one of these problems that we are going to work together, you have two variables, X and Y. It can be any other letters, but here we have X and Y. We will learn in this course that usually there are three distinct methods of solving a system of two equations in two unknowns. Okay? The first one that we are going to cover today is called substitution, and we'll see why it's called that. The second one will be called elimination. And then the third one is using graphing. So you will be drawing stuff, okay? So we'll use it in this exact sequence. So we'll start with substitution, then we'll do elimination, and finally, we are going to use graphing. And once we go to graphing, we will understand why do we call these types of equations linear, okay? Linear. You see that linear comes from the word line, so they form a straight line or straight lines. Well, yes and no. What do you mean, yes and no? I mean linear because most of the time we use only two variables, especially in this course. We say, well, when I draw a linear equation, I get a straight line. But later, you will learn how to solve a system of more than two equations. And they are still linear. But do you think there would be straight lines? There would be planes or hyperplanes that you cannot visualize, but you can solve. So our definition of linear will start to change slightly. I prefer a different definition of linear. Linear from now on, of course, here it's a straight line, yes. But once you add a z, so you have x, y, and z, it's no longer a straight line. But we can say that for two equations in two unknowns, or three equations in three, well, I have to add another word called independent. We don't have to worry about that for now. But three equations, three unknowns, four equations, four unknowns, and so on and so forth, will make some shape, whether we can visualize it or not, but this shape for sure is devoid of curvature. No curvature. So I have a line or a plane, like the plane of this desk or this paper, or a hyperplane in 4D or 5D or 10D that we cannot visualize, but we use the same logic and we say, even though I don't see that, or my mind cannot grasp it, I know it doesn't have any curvature in any dimension in it. This is too way advanced, but I wanted you to understand that the word linear, in this course, it means a straight line, but later on, you have to think of it as no curvature in that shape. Okay, so let's go down to business. So these are two equations in two unknowns. Sometimes you can have two equations in two unknowns that don't have any solution. How? Well, so easy. If I tell you x plus y equals 10, and the second equation is x plus y equals 11, duh. How come x and y equal 10 and 11 at the same time? There is no solution. Or if I tell you x plus y equals 4 and 2x plus 2y equals 8. I just multiply the equation by 2. So it's the same equation, because when I simplify the second equation, 2x plus 2y equals 8, I divide both sides by 2, I will get back x plus y equals 4. So x plus y equals 4 and x plus y equals 4. These are not two equations. You are tricking me. You give me the same equation twice, which means it's the same line, meaning I have infinitely many solutions. Any point on this line would satisfy x plus. So if I say x is 1, y is 3, 1 plus 3 is 4, and 2 plus 6 is 8. So it satisfies that. And then you give me any value for x. You say x is 2. I'll tell you then y is 2, because x plus y is 4. And you will have infinitely. You don't have to tell me 1 or 2 or 5. You can say 2.8. X is 2.8. Then y is 1.2. Any two numbers that add up to 5 or 4, one of them may be negative, the other would be positive. So you can see there are infinitely many solutions. Okay? So really, in any system of equations, linear equations, whether you have 2 variables or 3 variables or 100 variables, you have one of 3 cases. You will learn that later in more advanced courses, but I want to give you just hints of what's the meaning of that. You may have a system that has no solution. There is nothing that, like we said, x plus y is 10 and x plus y is 11. No solution. And we'll see what is the meaning of that when we go to the graphics, which could make perfect sense. Yeah, of course, there is no solution. Or I have a unique solution, meaning 2 lines that cross each other, and the point of intersection is what most of these problems would be. Or infinitely many solutions. You cannot have a linear system with exactly 2 solutions. That's impossible. Or exactly 3 solutions, or exactly 45 solutions. No, it's either none, 1, or infinitely many. Again, this is beyond the scope of Algebra 1, but just to see the big picture. Okay? And as I said, in the third lesson, so after substitution and elimination, when we go to graphing, you will see exactly what that means. Okay, let's go down to business. We call that substitution. What do we mean by that? It means that I will substitute one variable for another. And why do I do that? Because these are 2 things. I do not grasp my head around it. I can solve one equation in one unknown at a time. So if that was only x, I can solve it. If it were only y, I can solve it. So why don't I take one of them, the x or the y, and replace it by y or x? And you say, how can I do that? The way to do it is simple. You look at the x and the y, and you look at their coefficients. You see, for example, the x coefficient here on the top is -2, at the bottom is -1. For the y, at the top is 1, at the bottom is 3. If you have something with a coefficient of 1, substitute for that. It's easy. And we will see why as we go. So I can use y. And instead of y, every time I see y, I'm going to replace it with -2x plus 5. And my 2 equations now will become one equation with only x. And I can solve for x. And once I have the value of x, I'm going to plug it in the first or the second, it doesn't matter, and find y. Okay? And then finally, if you have time, we check the answer and see if it makes sense. So why do I say if one of the coefficients is 1 or -1 if 1 doesn't exist? The reason is, suppose someone will tell me, no, I don't want to use this y. I want to use 3y. Okay? I tell you, okay, 3y equals -x minus 5. So y, because on the top I have y. So y would equal -x over 3 minus 5/3. And then I'm going to use that and substitute it on the top. It becomes fractional. It's not hard. We are going to do fractional problems, but I wanted to go with the simplest first. Okay, not necessarily the same sequence you are going in class, but I want to get down with the integer numbers, and then we move to fractional and decimal. So I don't confuse you. Okay, so you see the problem would be fractional, but if I identify the y here, and I identify a y here, and I identify an x here, and I identify either or x or a y. I believe y would be easier because I already know y equals x plus 5. But if I want to use x, I would say x is y minus 5. I have to do some operations to get to separate x. Same thing here. I can use this y, but I have to do something to find it. So probably the first thing I do, I identify what I'm going to use and substitute for. Y by itself on the left-hand side, I don't have anything by itself, but I have a y. So that would be not hard, but it's more work. Here I have x also, it has something with it. So it would be a slightly more work. But the first and the fourth, I have y by itself. So if y equals negative 2x plus 5, I will go to the second equation and say 3, I see times y. No, I'm going to say times negative 2x plus 5. So I replace the y by what it equals. Equals, notice I'm substituting in the second. So I pick the y, find its value from the first equation, and then substitute it in the second. 3 times y is 3 times the right-hand side. Equals negative x minus 5. So you see here what we have? We have only one variable, like the problems we did before when we did multiple step equations. Now I'm going to distribute the 3 on the left-hand side. So 3 times negative 2x, 3 times, first of all, positive times negative is negative. 3 times 2 is 6, and I only have x, so I write x. Then I have 3, positive times positive is positive. 3 times 5 is 15, equals negative x minus 5. And now it became exactly like the problems we did yesterday, yesterday. I want the x's on the left-hand side, the constants on the right. So to get the x on the left, I'm going to add an x to both sides to get rid of that. So I will get negative 5x plus 15 equals negative 5. And most students, I know you do that. I didn't use this line before, but in the previous examples, but that's what you will see in school. So I want you to understand it's the same thing. So use whatever you are using. Next step, I want to move I don't want constants on the left-hand side. So I subtract 15. If I subtract 15 from the left, I have to do it for the right. And that will give me negative 5x equals negative 20. And finally, I'm going to divide both sides by negative 5. I'm not repeating that it's multiplied, so the inverse of multiplication is division, because we covered that before. So the left-hand side would be x. The right-hand side is positive 4. So x equals 4. Don't stop. We didn't solve the problem. What do you mean? I did. No, you did not. You found x. But the problem asks you to solve, meaning I need to find x as well as y. And now, since I already have, very simply, I substituted for y. I said y equals negative 2x plus 5. So I can go back and say y equals negative 2 times x, which is 4, plus 5. I distribute. Negative times positive is negative. 2 times 4 is 8. Plus 5, negative 8 plus 5 is negative 3. And y equals negative 3. Oh, sorry. Okay, now you can use the calculator to substitute. So notice we found x and y from the first equation. I said y equals, and I got -3. So there is no reason to substitute back in the first equation because I know it works. But we have to check the second equation. I can say the left-hand side is 3y, meaning 3 times -3, which is -9. What about the right-hand side? X is 4, so negative x is -4 minus 5, it's -9. So I know this is the correct answer. Now, let's work together the second problem. I said I'm going to use this y, because if I use x, I will get x equals 11 minus y, the whole divided by 4. So I will have fractions. No reason to do that. So I can just subtract 4x from both sides before I start substituting to get y equals -4x plus 11. Okay, if I'm going too fast, you can stop and see for yourself. I didn't do anything except subtracting 4x from both sides. So I only have y on the left. And then when I go down here, I say 2x. Notice I substituted for the y. So plus 5, and instead of y, I open parentheses and say -4x plus 11 equals 1. So I wrote the second equation in terms of x. As I said before, I'm going to distribute the 5 and then combine like terms, leave the x's on the left. It's the same, I don't want to say boring, but it's the same operation over and over again. We practice until it becomes so easy, it comes to you without thinking. So 2x positive times negative is negative. 5 times 4 is 20x. I have an x, don't forget the x. Positive times positive is positive. 5 times 11 is 55, equals 1. Now I combine like terms. 2x minus 20x is -18x plus 55 equals 1. I subtract 55 from both sides. So I get -18x equals -54. I'm going to divide by -18 both sides. So I get x equals 3. Like we did last time, this is not the end of the story. I use this to substitute. So I'm gonna go back to the same equation and say y equals -4 times x. No, x is 3, so -4 times 3 plus 11. Negative times positive is negative. 4 times 3 is 12 plus 11 equals -1. So y equals -1. Notice I substituted in the first equation, so I have to use my calculator to check the second equation. 2 times x, which is 3, plus 5 times y, which is -1, equals 1. Yes, equals 1. So 2x plus 5y equals 1. I checked my answer. Okay, so far so good. Let's move to the third equation. We said we are going to use the x because it's the only variable with a coefficient of 1. So you see, it looks like this one. It has something with it. So now instead, I'm going to work backwards. I'm going to solve for y before x. Why? Because I have the x is easily substituted. If I subtract 2 from both sides, I get x equals 2y minus 2. Then I'm going to use that and substitute in the second equation. 6x, no, it's 6 times 2y minus 2 minus 12y equals 0. Here we are going to see something interesting. I'm going to distribute the 6. 6 times 2 is 12y. 6 times negative 2 is negative 12. Minus 12y equals 0. Oh, 12y minus 12y is 0. So I get negative 12 equals 0. Impossible. So no solution. We call that system, I don't know if that's what they want, but we call this system inconsistent. Inconsistent because these two equations don't make sense. You cannot have negative 12 equals 0. So no matter what you pick values for y, you will always get something that doesn't equal a number that equals 0, which is impossible. So no solution. I told you we can have no solution, single solution, or infinitely many solutions. This is the example of getting one solution. No solution, I'm sorry. Now, let's move to the last question or last problem. And I think, yeah, it's taking long because it's an introduction. But this one is easy. It's like the first one. I already know why. Not know why. I know the variable y. I can say, oh, every time I see a y, I'm going to say, no, it's x plus 5. So that's a very simple problem. I have 2x plus y. No, not y. X, I don't even need parentheses, but I'm just using it so you can see. There is no distribution. I simply add. So 2x plus x is 3x plus 5 equals negative 4. I'm going to subtract 4 from both sides. So I get 3x equals negative 9. I'm going to divide both sides by 3, and I get x equals negative 3. X equal negative 3. Now, how about y? I already know. Y equals x, which is negative 3 plus 5. 5 minus 3 is 2. So y equals 2. So this system is consistent, meaning it has a unique solution or infinitely many solutions, but at least it has a solution. So it's called consistent. Now, we substituted from the first equation. Let's see the second equation. 2x, so 2 times negative 3, plus y, but y equals 2, equals negative 4. Yes, negative 4. And I checked my answer, and it's correct. And this is how easy it's to use substitution. Usually in the test or the homework, your teacher will tell you, use substitution to solve this problem or use elimination to solve this problem. But what if they don't tell you? You are allowed to use either one. What do you do? Again, do you see what we did here? If you have a variable with a coefficient of 1 or negative 1, like I could have used the negative x here, move it to the other side and say x equals negative 3y minus 5 and use that to solve. That's fine. But if none of them is 1 or negative 1, they are like 3 and 5 and negative 2 and 7, I'm not going to use substitution. I'm going to use elimination, which is the second method. So the second method becomes easier if none of these coefficients can be, is not 1 or negative 1. Okay, if all of them are numbers that have, they are completely different, then definitely elimination would be much easier way to do. So in the beginning, your teachers and your book would usually pick the easier of the two methods and tell you use that. But I prefer that in real life. you start thinking, which one should I use? Even if they tell you use substitution. Of course, for a homework or a test, you have to follow instructions. But if you see this in a different textbook, you see two equations. The first thing you have to think of is, do I have x or a y in these four? Because I have two x's and two y's. I have negative 2x and negative x, y and 3y. If one of them is by itself, like just y or just x, or as I said, negative x or negative y, yeah, you can use substitution. By the way, you can also use the elimination method easy if I have that. If I have one of them is 1. So from my perspective, I love or I prefer the method of elimination that we will cover next time, because it works every time, whether I have a 1 as a coefficient or not. The substitution becomes a little tricky if I don't have 1, because I will be dealing with fractions from the get-go. And I know that it's not impossible, but it's harder. It's easier to use integer numbers. You can say 5 minus 4 rather than to say 1/3 plus 2/5. You see what I'm saying? So it's just a matter of taste. I prefer the method of elimination every time. But it's easy to use the method of substitution as I showed you in these 4 problems, or as you see in these 4 problems. Okay, I know I gave you a headache. I keep repeating myself, but it's the beginning. Usually you try to spend time making sure that everybody understands what we are talking about. Okay, so if you have any questions or you see something that doesn't make sense to you, let me know in a comment and I will get back to you as soon as I can. Otherwise, I wish you all the best. Need to see you tomorrow to work with the elimination method. Bye.